What is up, guys, and welcome to Space Camp. My name is Andrew, and today we're going to be talking about power, a subject I have not yet talked about in these Space Camp videos, surprisingly. So power is a very important part of the game because everything uses power. So today I'm going to be talking about three main components related to power. We're going to be talking about how you generate power, we're going to be talking about how you store power, and finally we're going to be talking about how you use power. Let's get started. So in Space Engineers, every machine that you build requires power. So it's not only important to have power on your base, but it's also important to have enough power. And we'll take a look at that. So in order to generate power, you have three options. You've got the normal nuclear reactor, which is very small. You've got the large nuclear reactor, which is just a larger version of the same thing over there. And then you've got the solar panel. Each of these is a little bit different, and we'll go through how they're different and why that matters. So let's start out with the small nuclear reactor. So how much power does the small nuclear reactor generate? Well, if we go over here onto the control panel, we can see that the max output is 15 megawatts. This means that this nuclear reactor has the potential to output at least 15 megawatts of power. But the current output only says 0. Why is that? Well, the nuclear reactor requires uranium to use. So we have to add uranium for it to actually say anything in the current output. So let's add a little bit of uranium. Here we go. Let's add some. We'll add 1 uranium to see what that does to it. And there we go. It looks like the current output is now 15 megawatts, which means this nuclear reactor is operating at full capacity to power our base. That's good. Let's take a look at its parent, the larger edition of this one right here. So going right into the control panel, it looks like the max output of the large nuclear reactor is 300 megawatts, which is way more than the small nuclear reactor. So this one has much more potential to power things in your base. Where you may need multiple small reactors to power your base, you only need one large reactor, depending on how many items you have. But the current output is 0 watts again. So let's add some uranium just to make this a little bit higher. We're gonna add 1 uranium here. And there we go. Let's take a look at the control panel again. Oh, this is interesting. It's only 68 megawatts instead of the full 300. Well, why is that? You can see that the number is slowly going down. In order to conserve uranium, Space Engineers only allows the large nuclear reactors, or any power generating tool for that matter, to generate power where it's needed. So this is not going to use uranium as fast because it's only generating 22 megawatts and falling. It's actually fluctuating around 22 and 23. It's only going to generate 23 megawatts of power because that's all it needs. It doesn't need to generate the full 300 megawatts of power for what we have on our base. But whereas when you go and look at the other one over here, it did in fact need to generate the full, well, I guess it doesn't anymore, but it did earlier need to generate the full 15 megawatts to power our base. So Space Engineers conserves uranium in that way, and I'm very grateful for that. Finally, over here on the left, we've got the coveted solar panel going green in Space Engineers because it's extremely important when you're the only person on the planet. But nevertheless, the solar panel. You don't require uranium for the solar panel. Instead, as you may have imagined, the solar panel collects power from the sun based on where the sun is in relation to the solar panel. So if the sun is overhead, directly overhead, like it is right now, sort of, it'll generate 4 to 3 bars. That is the max power that the solar panel will generate. If, however, the sun is kind of over a mountain or something like that, it'll generate 1 or 2 bars, whereas if the sun is completely on the other side of the planet, it will generate 0 bars. But how much power does the solar panel generate? We'll look at its max and current input, actually. So the max output of the solar panel is 76.75 kilowatts, whereas the current output is also 76.75 kilowatts. Now, why such a weird number? Well, the maximum output displays the maximum possible output at the current moment. Now, if the sun changes directions, the max output might fall because at that current moment, the maximum possible output of that solar panel is lower. Whereas if the sun is higher, this might actually rise. So the maximum output of that solar panel is actually higher. But usually the current output will always be the same as the max output in this case, as long as the solar panel is being used. Just like what we saw with the large reactor, you know, sometimes it might not use all of the possible output depending on how much your base needs. But as you can see, and as you probably imagine, the solar panel is not nearly as powerful as those reactors. They're a little bit, you might need a little bit more solar panels to generate the same power. So now that we know how to generate power, how do we store it? Well, you can store your power in the form of raw uranium like we were doing earlier. So as I showed with the large reactor, it doesn't use uranium unless it actually has to. So unless it has to actually power machines, which means you can just throw all your uranium inside a nuclear reactor and it won't use it until it's actually needed. But if you want to store more power in a more efficient way or in a better way, in a more elegant way, you're going to need batteries. Let's hop on over to our little battery bank over here. Now, it's important to know that no wires are needed for anything when it comes to power. So in order for our generated power to get to a battery or to a machine, or from battery to machine, we don't have to actually do any wiring. It's assumed that the wires are inside the grid. So as long as your generating thing and your battery are on the same grid, you're good. And as long as your battery and your machine are on the same grid, you're good. They're already connected. You don't need to do any additional connecting. So let's hop into the battery and see what settings it has. So looking at the bottom right at the battery settings, it looks a bit confusing. So we've got a couple of different settings here, and we'll talk about the output a little bit later. We've got a max output, we've got a max required input, we've got a max stored power, so that's how much it can store total, I guess. We've got a current input, we've got a current output, we've got stored power currently, so this is the current amount compared to the max, and then we've got fully depleted in this time. Now, like I said, we'll talk about some of these a little bit later, but the ones we want to know about right now are the max required input, the current input, the stored power, and the max stored power. The max required input is the maximum amount of input that you can have currently. So that's how much input can be happening right now. So the battery can take in 12 megawatts of power, which means if we were to give all of our uranium to this guy right here, how would that change? Let's take a look. It looks like our current input is the full max required input. So the current input is 12 megawatts. That's because we've got this gigantic machine feeding power into this thing. Now I don't want it to eat up all my uranium, so let me just grab that back. I need it for a couple other demonstrations today. Now, just for demonstration purposes, I'm going to click on recharge. Essentially, this turns off the output and makes it so that the only thing that this can do is recharge power. It can't actually give away any power. Discharge, what that does is it completely outputs everything from the battery without recharging. And then semi-auto, once it goes all the way to 0 power, stored, it'll start recharging. And then once it goes all the way to full, it'll start discharging. It just goes back and forth. But recharge, we're going to do that for demonstration purposes for now. So we can now see that the current input is 12 megawatts, and we can see that the stored power is actually increasing. And instead of saying fully depleted in X time, it says fully recharged in 6 minutes. Since we're inputting way more than we're outputting, that means we're headed for an eventual full recharge, which means we'll be reaching that 3.0 MWH. I guess it's time to explain what MWH is compared to MW. Now, I'm not really great when it comes to electricity and physics, but essentially an MWH is a milliwatt hour, which is 1 MWH is how many watts you can use in 1 hour, how many megawatts you can use in 1 hour, I believe. So where currently we're taking in 12 megawatts, that means we're taking in that much power at the current moment. This is talking about how much you can use in 1 hour. So we can use 1.97 megawatts in 1 hour of time. Now, how right am I? People in the comments, please help me out with megawatt hours, or help anyone watching this video out, because I'm not a professional when it comes to knowing the difference between a megawatt hour and a megawatt. So look down in the comments for an answer on that one. But anyways, that's how you store power. You just store it like this, and if you have enough batteries, you can, like, if you reach that 3.0 MWH maximum, you can have another battery, which we have this one right here, which is currently only at 1.15. You can have more batteries. If you look over here, when I was designing this base, I actually created a little battery bank right here, and they should be almost fully powered. But yeah, you'll see the more batteries you have, the more power you can store, and the more power you can store, the safer you can be from eventual power outages. Now, everything we've talked about thus far has been relating to large grids, but I think it's probably about time we talk about small grids. And I don't think I've talked about them very much in this series yet, except for when we built that ship, which was last episode. If you haven't checked that out, it's a really good one. Intro to Flying Ships is what it's called. But small grids are essentially smaller versions of everything on a large grid. So naturally, the smaller editions of these things, don't they look so cute? It's like a little small large reactor. Now, I compared this to father and son, but really this is son and father, and this is son and father as well. But let's take a look at the statistics for these ones before we go into how to worry about usage of power. So the small little thing right here, instead of 15 megawatts, it can only output 500 kilowatts. Now, for your information, 1,000 kilowatts is equal to 1 megawatt. So where the other one could output 15 megawatts, this can output 30 times less than that one at its maximum. So, you know, once again, all we need to do is add some uranium. Let's throw some in there and take a look to see what's happening. Yeah, there we go. Maximum output right there. This one, on the other hand, can output up to 14.75 megawatts. So this is actually less than one of those little small things right there. It's actually about the same. And I guess they're about the similar size, right? I think so. But let's throw some uranium in there and see how that does it. Press F. By the way, what I'm doing is right-clicking and then bringing it over with right-click and then clicking on one to bring over only a certain amount of uranium. So there we go. Let's take a look again. And it's outputting. It's not outputting full, but once again, that's because we don't need all of that power. In fact, that's probably showing that the battery is at full capacity, full input capacity, rather. Yeah, the battery is at full input capacity. So that would be why that is not full. Finally, let's take a look. Well, finally, I mean, let's take a look at the solar panel. So the solar panel is going to be quite a bit less for this thing. It's only 19.58 kilowatts at 3 bars. So that's definitely a bit tough to get power with those solar panels, but I'm sure you could do it. You know, if you have enough solar panels, it'll work out pretty well. And we'll see our current output's the same thing. And we already took a look at the battery, but let's take another look just to see. We can see that the max input is only 4.32 instead of, and it is in megawatts, instead of 12 megawatts. We'll see that stored power is about a third of what it was on the other one. And we'll see that, well, the current input's pretty small as well, just because yeah, just because we're inputting with only that thing right there. But now we've talked about all of the inputs, or all of the generating of power, and all of the storing of power. It's time to go into how do you use your power, and how do you use it responsibly. This is where we're going to get into the output section of that battery that I didn't talk about. By the way, why is this one at 3 bars and this one's at 1? That's because this one is on recharge mode, whereas this one is not. So this one is still outputting, whereas this one is not even worried about outputting power. So any machine on your base uses power. So this thing right here, the refinery, which has been chugging along this whole time, I gave it 100,000 cobalt. So it's definitely going crazy here. This is using power, but how much power? So we'll see in the refinery that the max required input is 560 kilowatts, whereas the required input is the same thing. Now, I'll admit, I don't know what the required input is compared to the max required input. If anyone knows that, please post that down in the comments. So check down there if you don't know as well. But for what we're doing, the max required input is all we need to know. And that is the input that is required to make this machine run. So it needs 560 kilowatts, which means if we're not generating at least 560 kilowatts, this machine is going to have trouble. Luckily, though, we're generating quite a bit more. We've actually got the solar panels on the case. How much is the solar panel generating, actually? Let's take a quick look at our solar panel to see. It looks like the solar panel is not generating enough. So let's try a little experiment. We're going to turn off all of our batteries and see what happens. So turn all of these babies off right here, so that the solar panel is the only thing now generating power. Now let's go see what's happening with the refinery. You hear that sound? That's not a good sound. That's not something a refinery should be doing. The reason is that the required input is 1 kilowatt. Oh, I guess, okay, so I guess this is the required input. I still don't really know what that is, huh? But we'll see that it's not getting its maximum required input of 560 kilowatts. It's instead getting quite a bit less. And as a result, it's having problems. So what do you do if you want to run a refinery and all you have is 1 solar panel? Now that's a bit of a weird situation. Usually you just create more solar panels. But what if you can't? Well, that's where a battery might come in, because what you could do is you could turn this machine off and then allow the battery to store charge. So let's turn this battery on and pretend that this has stored charge for about an hour, and we'll see that this now has a stored power of 895 kilowatt hours, which is actually enough for this thing to work. That's enough for the machine to work over there. And we can see that the max output of this battery is 12 megawatts. Which is more than enough for that machine to work. So it's got enough power stored, and it's got enough output. So let's go see if the machine's working now. And in fact, it is. We'll see that, I mean, we're getting that power. We're getting the machine working. We can see that it's actually working. So there we go. Even though we only have 1 solar panel, the battery has allowed us to store enough power to then output that to this machine. Now that was a pretty simple example, but what if you have multiple machines? How do you know how much power you're going to need to generate in order to run multiple machines? This is where a little bit of math comes in. Let's write down some numbers. So this requires 560 kilowatts. I'm going to write that down on my handy dandy paper. Now let's go on to the next machine. We've also got a gyroscope. Let's see how much this requires. 30 watts. That's actually like nothing. All right, next, I think we have, do we have anything else over here that requires stuff? Well, we actually have a couple of these things over here. Let's see how much these require. So how much do you require? Oddly enough, the medical room doesn't have any statistics here. Is that because I have to go here or something? I know that the medical room requires power, so I don't know why it's not showing anything, but I guess that's some weird thing with the medical room. The oxygen generator requires 330 kilowatts. The oxygen tank requires 1 kilowatt. The hydrogen tank that we have requires 1 kilowatt. We've got an LCD, which is the one when we first start that says "Welcome to Space Camp," that requires 200 watts. Now it looks like that's all of the machines on the base. So let's calculate our final power, our final power output, so that we can know how much we're going to need to input in order to run everything. So for our machines that display kilowatts, the total is 892. For our machines that display watts, the total is 230. Now there are 1,000 watts in a kilowatt, which means that our total power that we require to run all of our machines at this given instant is 892.23 kilowatts. So let's see what we can do to get that much power. So I've turned off our solar panel. At this point, we have 0 power coming into the base. So we can see this because the, we'll see our LCD panel up here. Let's see what that says. Okay, so the LCD panel is offline, meaning nothing is pretty much working. There's no power going to the base. Let's see what we can do. Well, we need 892.23 kilowatts. This thing right here is going to output 15. It says current output is 15. I think that's a glitch because there's actually no uranium in it. Let's throw some uranium in there and see what happens. Press K, and we'll see that it's now outputting 563.56 kilowatts, which is a little bit lower than we needed. But it's possible that some of the machines that we accounted for aren't actually running right now, even though the refinery should be running. We should hear it running at full capacity over here. Yes, sir. It's running at full capacity. We should see that our LCD sign over here is turned on. Yes, it is. Welcome to Space Camp. And other than that, yeah, it looks like everything is accounted for. These are working. We can get power from here. This is working. We can take stuff from there. But yeah, once again, it's possible that some of the machines just aren't running right now, which is why it was displaying a less number than what we had accounted for, which was 892.23 kilowatts. But that is how you determine how much power you need to output for your base. Now, before I leave you, let's take a look at one more example. The ship we built last episode, this small little thing. Let's do some mathematical calculations to determine exactly how much power we need for this thing. Let's hop into our ship and let's press I. So we're going to take a look at all of our thrusters. Now all of our thrusters are the same. They're the same exact thruster, and they require 701 kilowatts to run at any given moment. So let's calculate everything. We have 8 thrusters, each using 701 kilowatts, which means 701 times 8 is going to be 5,608 kilowatts. That's how much we're going to need. 5,608 kilowatts is also 5.6 megawatts roughly. So if we want to run all of these thrusters at the same time, we're going to need to make sure that our power source, which in this case is our battery, has at least 5.6 megawatts of output. And it looks like it doesn't. It actually has a max output of 4.32, which means if all of these thrusters were running at the same time, we would actually run into some power problems. We wouldn't really have power problems. We would just have the thruster not performing at its maximum, because whereas a lot of machines on your base will simply not run if they don't have enough power, these thrusters will run at a lower efficiency. So they'll actually not provide as much thrust if they don't have enough power. So where it may be a little bit difficult to show you all of the thrusters being used at the same time, let me reposition a couple of these thrusters and I'll give you a good look. Here we go. I've repositioned all of the thrusters such that we have 2 pointing down and we have 6 pointing backwards. So we have no thrusters pointing forward and we have no thrusters pointing from side to side, which means we're not going to be able to stop essentially, but it's going to be good. This is for demonstration purposes only. So what we're going to see is that if we go up and forward, we're going to be using all of our thrusters to their max capacity. So we'll be able to see how much power we're using in the bottom right. So let's hop into our ship. You'll see in the bottom right, there's a power usage icon. There we go. We can go up and we can see that the power usage is only 26% while we go up. But when we go forward, we'll see that it's more than 100%. So what you can take from that example is when you're building a ship, you can determine which thrusters are going to be used all at once. So the maximum number of thrusters that will be used at the same time, combined with all of the machines that are going to be on your ship. And then you can calculate the max required output for your ship. And then you can determine the max required or the minimum required input that you're going to have to be able to run that thing 24/7. Well, there you have it. Everything that you need to know about power in Space Engineers, how to generate it, how to store it, and finally how to use it, and how to calculate how much you're going to need to generate in order to use it 24/7 without running into power outage issues. If you have any questions, please post those down in the comments. And if you like the video, please hit the like button. Put your comments and your suggestions for the next Space Camp video down below in the comments section. I'll see you guys in the next episode of Space Camp.